AWS Lambda is a compute service which offers a development platform, supports a list of languages where you can develop your code, place your code, and Lambda takes care of running it on their infrastructure. So this is what AWS Lambda is all about. So what are all the features it offers? Main thing is, since it runs on AWS platform, it offers high availability, which is the most important concern that we look forward in a normal day-to-day application. So these are all the main things that we expect from a day-to-day application that is run by software companies. So high availability is expected from any website or any service that is available. And scalability is a big concern, especially with one example is an e-commerce market. Like say, scalability is a concern, and other banking industries also look forward. So scalability, especially during peak seasons. So since it runs on it, this is one of the key expectations. AWS Lambda offers a solution for this. Fault tolerance. So your service needs to run, or the website, your applications needs to run without any faults, or even with respect, even if there are any faults or issues during your service, the service needs to be up and running, irrespective of any of your components being failing in any scenarios. And responsiveness, quick responsiveness, meaning think of a scenario like most of the applications that run currently in the market, or say covered in a scenario like event-based programming, most of the cases. So in where like you need to respond to events. You need to take action on various type of events that are provided by applications. Applications try to emit various set of events for which you need to take actions for every event that is getting generated, for which the system needs to be quickly responsive and acting upon. AWS Lambda in fact offers one use case. And the services that you launch needs to be highly secured. In on-premise and other cases, you need third-party softwares and other things to secure your applications, run behind the firewall, enable IAM roles, and things like that will be there. So how we do this with Lambda, we'll see that. So AWS Lambda, so you develop your code and just upload it to the code to AWS Lambda, which is called as a Lambda function as such. So Lambda function is nothing but your code, whichever you upload, and name it with a function. You can name it with you can name a function with your code, and you can just upload your code, and the Lambda will take care of running it. It runs across multiple data centers, multiple regions, multiple AZs. So you need not worry about any case of failure as which you expect during a on-premise scenario, or if you handle this such scenario manually. Say you run your applications on a EC2 box, you need to take care of handling all these failure scenarios. You need to take care of spreading across your workloads across multiple regions and multiple data centers, multiple available systems. You need not worry about the same thing when you upload your code and execute it in case of Lambda. And auto-scaling. Since it runs on AWS infrastructure, forget about your auto-scaling that you do on a day-to-day basis when the load changes. So you typically use a load balancer and other stuff which act accordingly in response to various set of loads, and scale accordingly. Downscaling and upscaling manually will be a pain point during a normal scenario, which can be avoided using Lambda. And access controls. With respect to access controls, if you're running on EC2 host, you need to put it things like you need to put it behind VPC, maintain it. You need to provide a gateway and access points. You need to provide proper access points to various servers, from app servers and web servers. You need to create proper connectivity between those, and things like that will be a manual task. If you are going here, you just upload your code, enable your Lambda function. You can limit using the basic IAM rules that are available. IAM rule is nothing but the access control system, your user management system, using which you can limit access controls to various resources available in AWS infrastructure. Similar way, you can control your Lambda functions, who can execute those Lambda functions. And things like that can be controlled in Lambda. This is what Lambda offers with respect to what are all the issues which we normally think as a pain point. And so as I spoke, These are all the major issues, current limitations which we face, like auto scaling we need to do manually, like adding hosts, downscaling hosts whenever there is a not low, whenever you don't see load on your applications, and maintaining your environment. This is like, say you have your host running, host running your applications. There might be cases where your code might need latest set of patches, like say security measures, some SSL certificates needs to be updated, things like that will be there. So since if Lambda is going to be running your application, you need not worry about taking care of maintaining the latest state of softwares on the hosts that are run. Since it runs on AWS infrastructure, they take care of updating the latest patches, maintaining the environment. So it becomes it makes lives of developers easy. Managing the deployment. So thing is like deployment with Lambda is like pretty much easier. Like you just develop your code. AWS Lambda provides an option to directly it provides an editor where you can directly edit your code inline, or otherwise you can upload your code, just zip it. If it is going to be a Java code, you can upload it as a jar file or a zip file. If it is going to be a Python, just wrap up your code, build your packages, download your packages, whichever is needed, pack it, zip it, and upload it there. You can also upload it to S3 for faster uploads, or sizes that take that is like say I guess 10 MB, I guess more than 10 MB of source code. You can just upload it to S3, which is like easier to upload. From there you can directly link it here to take the Lambda function can link it to a specific S3 object where the actual code resides. And manual security measures, you need not worry about, as spoke earlier, you need not worry about maintaining security for your manually maintaining security for your applications. Since it runs on infrastructure, it takes care of all security and other stuff. Code monitoring. So in real world scenarios, if your service is running on specific EC2 instances, you need to take care of monitoring your status of your applications, whenever there is a service failure, whether your service is up or not, whenever there is a spike in your infrastructure like memory or CPU of the host, you need to take care of and you need to be monitoring those in the key parameters on the host, and you need to be taking care of taking appropriate actions on that. In this case, like how Lambda offers us. So what Lambda, since it runs on AWS infrastructure, you need not worry about that. It provides various monitoring systems where you can monitor and other stuff. I'll talk about Lambda before talking about that. So what is AWS Lambda? As spoken earlier, it is a compute service offered by AWS, where you can just write your code, forget about your infrastructure, and AWS Lambda takes care of running it. It is a serverless computing platform. So key thing is zero administration. If you are going to be maintaining your EC2 instances to deploy your applications as you do today, you'll need to take care of like managing your host. You need to scale your host vertically or horizontally. Things like maintaining your load balancer, things like that will be there. If you are going ahead with Lambda, you can totally forget about administration and maintenance of your infrastructure. AWS takes care of AWS completely takes care of it. And one beautiful feature is like just bring in your code. AWS Lambda doesn't limit yourself by applying you like specific syntax or specific code. So it just asks you to bring your code. It supports 3 languages as of now. Node.js, initially it was launched with Node, later supported Java and Python. I guess other languages are in pipeline. So you just need to wrap up your code as told earlier. Just zip it, upload your code. You don't need any specific syntax apart from what you do in your day-to-day life. So it makes lives of developer easy to adapt to it. So we have been using it for quite some time now, at least for 2 months. So it is pretty easier for development, and especially with if you are developing with a Node or Python, the inline editor will help you a lot, because for simple programs you can try out. Probably in the demo we can see like how you start off with that. And subsequent billing. So this is one key factor which will be a key impact when compared to your current scenario of running your applications on-premise or EC2 manually maintaining your EC2 instances. So subsequent billing. So during your peak load season, if you are trying to increase your EC2 instances to accommodate the load of your applications, you will be charged even when you are not handling the load. Especially like say you have increased your load during a peak season, like say Diwali or Christmas, probably you need to downscale, or you'll be charged for until the hosts are up. So we need to manually maintain and take care of handling the hosts that are provisioned. So during that time you'll be charged. So in case of Lambda, the subsequent billing is a key feature. So they charge your code, like say they charge not $1, I guess, for they charge for every 100 milliseconds of code that gets run. So you are not charged when your code is not running. So you'll be charged only when your code, how long it takes to run and the number of times it gets triggered. So this makes your a significant improvement in your bills especially. So what are all the services that are integrated? These are all the services that can be integrated with Lambda within AWS infrastructure. These are all the AWS services that can be integrated with Lambda. So what are the services? So S3, SNS, DynamoDB, Kinesis. From these, AWS Lambda can receive data. So how AWS Lambda works actually? So you upload your code. How does it get triggered? Before going to this, I'll just give an overview of like how it works. So since I spoke about event-driven programming with Lambda, Lambda needs to trigger your codes on certain events. So what are the events that it listens for? So for example, say S3 events, assume like S3, you do a lot of changes with your S3, like say upload your object, delete a bucket, or things like that are there. These are all events. So AWS Lambda can be configured to listen for S3 events and react accordingly. Your Lambda function can literally take any action inside the Lambda code, can literally take any action listening to such events. Assume like say there is a deletion of a particular object, during when say your Lambda function can be written something like say take a snapshot of that, take a backup of this, things like that can be written as a remedy. So whenever there is a deletion of an object, this will get triggered and we can take a backup of that. So this is a simple scenario which I am talking about. So Lambda reacts on events. What kind of events it offers? So there are like say it is just classified as events. I am talking about is like say it works in two ways. One is like pull mechanism and another one is a push mechanism. So pull mechanism is like say in case of DynamoDB and Kinesis. I guess DynamoDB, I'm not sure if someone is not sure, like DynamoDB is a NoSQL database offered in AWS. Kinesis is a stream service that is offered in AWS. So AWS Lambda can listen to these streams and it pulls the events whichever is responded from them. So AWS Lambda, you can write a function to listen those events, and in this scenario, when it listens to DynamoDB and Kinesis, it is in a pull model actually. It is implemented in pull model where the event sources are getting pulled from the streams. And I guess the stream data with both DynamoDB and Kinesis lies for around 24 hours. Lambda offers a mechanism for failures. Like it offers retries, it by itself offers like 2 to 3 retries if I'm not wrong. And yeah, even for further scenarios, even if it gets failed, the stream data will still remain in the streams for close to around 24 hours. So you can still reuse the data and proceed for further retries manually if you want to do. And with respect to S3 and SNS notifications, in this case Lambda works in the push model, where the events are pushed from S3 and SNS side. So you get receive, you try Lambda functions receive events from the other end. It doesn't pull. So it just receives events from the other side, from S3 and SNS, and on it, and once it receives, it gets the Lambda function gets triggered. These are all the two types of events it works on. And apart from this, other type which you usually do is a scheduled execution of a code on a scheduled manner. Something like, say, you work on a cron based, your application runs on a schedule using a cron or something like that. Lambda introduced it recently with the option of executing your code on a scheduled manner. It it is predefined with a specific set of intervals, I guess, 1 hour or half an hour, I guess. I'm not sure about like exact intervals, but you can execute on specific intervals if you want. So in that case, it works on scheduled manner. So S3 SNS works on push models, DynamoDB Kinesis works on full model, CloudWatch, and okay, CloudWatch with CloudWatch. Okay, CloudWatch is a service in AWS where you can log your data. Your applications can log your data. CloudWatch can receive your log data, on which you can using Lambda you can action on the log data that is getting published to CloudWatch. So you can configure a Lambda function to integrate with CloudWatch so that you can listen to log data that are getting published in CloudWatch and react accordingly. So apart from this, AWS config. This got AWS config. Okay, config is a service where it listens to configuration changes and other changes with respect to resources in your AWS infrastructure. So AWS config records all the configuration changes, and Lambda can be integrated with AWS config, so that it Lambda function can react upon all configuration changes and other with resources, and even the tag changes. In AWS config it offers like whenever there is a change, whenever you add tags or remove tags for your resources, that also gets tracked in AWS config. So that also if you integrate that with Lambda, that is listened as sent as an event, and you can react using Lambda accordingly. Alexa is a voice recognition system provided by AWS. You can probably integrate Lambda with Alexa to react upon recognition which you receive as input from Alexa. And IoT as well. IoT for mobile applications and other things, you can use this thing. So API Gateway is a service. API Gateway is a service which provides algorithm provides APIs with various set of algorithms. So apart from this, I'll just brief about few key features about Lambda. Like with Lambda, like you can just run your code for 300 seconds max. Earlier it was like say 60 seconds. They recently raised during the reunion, they raised it to 300 seconds. So your applications can run only up to 300 seconds. Your specific Lambda function can run only up to 300 seconds. If your limitation which we have, you can consider it as a limitation, or you can it is more specific. Like I guess within 300 seconds we were able to achieve like most of our use cases accomplished. For a long running process, this might be a drawback. And
we have to say this for the request processing.
So yeah. Apart from that, one important thing that Lambda mandates is your application needs to be stateless. That is because since it runs on AWS infrastructure. So assume like if you try to process some data on your host and try to read from that on your subsequent request, probably this might not be your scenario. You need to maintain the state of the application elsewhere, like storing it in DynamoDB or either ODS or S3 somewhere else. So since it runs on AWS infrastructure, it gets provisioned every now and then. So once you make your request, the EC2 host or the container service that runs behind gets spawned by then. So you can't rely on the data that gets put there. So all your Lambda functions can be triggered both in synchronous manner and asynchronous manner. For synchronous activity, I guess the UI, once you upload the function, the UI has a test button. Once you click the test button, it gets invoked synchronously. Apart from that, the AWS CLI. I guess SQS has an integration with SNS and the same message limit. I guess 256 KB of data is available both in SQS and SNS. I'm not sure why SQS is not subscribed to Lambda. But as an workaround, we have used, in fact, like to subscribe SQS messages through SNS to Lambda as a workaround, but I'm not sure like why SQS is not yet offered.
Yeah, SQS is not a event source today for Lambda. So while SNS is, but SQS is not. But any specific use case that you're looking at for SQS?
One thing is like we are thinking of probably using SQS as a alternative to Redis for some of our background jobs, which like the worker can pick up stuff from SQS.
Yeah.
So I thought we could probably migrate our workers to Lambda.
Yeah.
And they can automatically read from SQS.
Yeah. Yeah. So you will need to have SNS in between. So where you will have a SNS topic which gets updated as and when necessary on SQS, and then tie Lambda to SNS. Yeah. So today we don't have a direct integration with SQS because the data model is slightly different for SQS, right? Where it's primarily a distributed queue, and it's going to kind of go on to retain all the data forever. So today we don't have a direct integration with SQS, but yeah, it probably could be in the roadmap.
But is there any reason why they specifically left it out? Because it makes very obvious sense, right? Like Lambda is like a background worker kind of a thing, available background workers.
Yeah.
And SQL is primarily meant for meant to be like a job queue for your workers to pick up stuff from.
Yeah. There's no specific reason, just that we are adding one by one as even so that's about it.
Probably in that case, your SQS consumer can just trigger the Lambda function. If that is going to be the case in the workaround, instead of
I was
going
thinking the Lambda itself could be the SQS consumer.
during that case, for an easier workaround, we use SNS as an alternative to tie both SQS and this case. Otherwise, the SQS consumer need to trigger your Lambda function. You get synchronous response. Apart from that, you can just regular code executions in AWS Lambda takes. Especially in Java, it executes asynchronously.
The 300 seconds limit that you mentioned, right?
Yeah.
So Lambda is basically it runs on some computer instance which you want to bother about.
Correct.
So while you're creating your Lambda, whatever that thing is,
Correct.
do you have to specify like which type of instance you want it to run on? Or can you specify?
You cannot specify the instance. However, it offers.
You can choose the memory. Okay, so memory you can choose. All other things are like predefined by AWS, and they will choose what kind of instance they have to run.
So if at all your application fails on due to a limitation of any specific instance, they try to retrigger with a higher version. So it is taken care internally by Lambda. So we literally avoid, and even the retries are done instantaneously. I don't know how they compute inside like before. So they execute most of the times it doesn't get failed due to a limitation of infrastructure. So we haven't seen any such failure. But however, we face something like timeouts due to services that are invoked within Lambda functions. Things like say you try to invoke DynamoDB, put record or say S3, and in that particular region, if you face any issues on those services, probably you face timeouts in that cases. So these kind of scenarios which we usually face, but we never faced anything specific to infrastructure. But from that memory-related issues, probably we have seen, I guess, once, but not much. You can configure like what kind of memory, what amount of memory you need to allocate for a specific Lambda function, and they can also specify the timeout up to a maximum of 300 seconds.
You want to run, and you choose how much amount of memory you want to allocate for the function, for every run of the function, and you specify the timeout. So from 1 second to up to 300 seconds, you can choose what's the timeout value. When you specify a memory, we automatically throw an apportioned CPU to the function. So you can choose from 180 MB to about 1.5 GB of memory for single function run, and we automatically throw CPU to the function. So CPU is not something that you decide. You decide only the memory that you require, and you don't have to choose instance types, just the memory that you choose.
So there was a choice of selecting Node.js, Java, and all that. Do you have anything with the OS?
No, you don't have to choose OS. The whole idea is basically where you don't have to plan any infrastructure. where you just give us a piece of code. Do not worry about capacity planning or sizing of your infrastructure. What you worry about is how long the function runs, how much amount of memory the function needs, and tie the event source, like all the event sources, and we will take care of running it. So you don't have to just do any kind of capacity planning at your end.
Default operating system is Amazon.
Yeah, you would run on Amazon Linux. Yeah.
How about that? So security patches, there is one thing is mentioned like about whenever there is some latest patch has been installed, has been released, so it will automatically gets not automatically, some maybe some after performing some benchmark that might be introduced, right? So we get any sort of notification of okay.
No, so we completely
benchmark.
manage that. We completely manage that. So since it's completely, so the entire infrastructure is kind of abstracted to you. So since you give only the function to us, we take care of running that function on our infrastructure, right? And we make sure the infrastructure that we run is up to date in terms of security and all aspects. So you don't have to worry about that.
Because in general, like before we get any.
So you could figure out that it runs on Linux-based infrastructure. You do not know whether it is Amazon Linux or Red Hat or what sort of OS runs behind that.
So, I mean, I understand the underlying operating system is extracted away from us, but if my code uses any native libraries, for example, how am I supposed to package it and send it along with it?
What kind of
I mean, let's take an example. If I'm using an SQL component, or if I'm going to use a RocksDB database with my Java application, or any of the node modules that I have, which compiles down when I do an npm install.
Yes.
How do they?
You can bring along all of that. So if you're writing on Node and you probably want to use some of the Node modules. So what you can do is before uploading it, so obviously do an npm install and then compile and then give us the entire package and we run the entire package.
But my certain modules are binary dependent, right? So it depends on the underlying architecture where I need to
You should
combine
not
it.
write a platform dependent code. Like, see, my code needs to be run on only Linux machine, that too Red Hat machine. So that kind of restrictions are there. Yeah. So whatever libraries you are dependent, you have to package it with the code and you have to upload it. That's it.
Okay, so I need to precompile it
Yes,
again.
Precompile it and then.
So which means we know what operating system you guys are running already.
Yeah. So if you need any specific OS libraries or if your code is dependent on some specific drivers on a particular OS, you may not be able to bring everything along. So yeah, that will be restricted. But any higher level libraries, for example, let's say
Like
you
runs
are
within the VM.
VM, anything within the VM should be. So for example, anything that you run on any virtual machine that you spin up on Amazon, you should be able to do it. On an Amazon Linux. Yeah.
How do I package that and put it on my laptop? It's not something you can compile, right?
The Python library for Cassandra, is it?
Yeah, I mean the driver and the library. The library I can import, but I need the underlying driver for the library to actually be able to talk to the server.
Yeah, we package most of the underlying drivers. So if it's a Python environment, we package most of the popular underlying drivers. So if it's a Cassandra driver that you're looking at, it should be already packaged and available. So for example, the AWS SDK itself, right? So it's already packaged and available as part of the Lambda environment. So we pre-package that and make it available for you. Most of the popular ones. But yeah, so Cassandra is very popular, so it is already packaged and available as part of the Lambda environment.
Isn't there a way where, like before your Lambda function executes, there like you use either like something like chef or just configure that instance or that compute whatever the terminology before it starts the computation? What if there's something I want to do which is not already there?
Such as any binaries, any.
I guess you should still be able to do that. It's just
Yeah.
gonna cost you against your computing that you're gonna do. There is no hooks for pre-start and post-start,
Yeah.
I guess. So that's a cost of extraction.
Yeah, so obviously it's not something that will work for all possible use cases, right, in the world. It's primarily for a lot of event-based use cases where you just want to run some kind of function in response to an event, right? So while we would support most of the libraries that you are looking at. So some specific things might not be supported. Putting your code which works with DynamoDB or S3, you will still pay for Dynamo or S3, right?
Because when we focus this on the client, they will think about, oh, Lambda charging only this millisecond, that's it. They won't think about this.
Okay, so Lambda is like this. So EC2, right? EC2, you spin up a VM and you pay by the hour, right? So EC2 is charging for how long you are running a particular compute resource, right? While from the EC2 you can talk to other services, and if you talk to them, we will charge that separately, right?
Yeah, that's right.
It's the same model where Lambda is just giving you a compute resource and we are billing you at 100 milliseconds instead of 1 hour.
No, when you say Lambda is a complete package where you don't need to bother about anything. The client also think that, okay, I need to pay only for Lambda. They don't bother about.
So just go ahead with how to create. I just give a small demo on how to create a simple Lambda function. So just create a, you will find a Lambda thing here. Just create a Lambda function here. You are provided with a list of blueprints. These are all. Okay. If you're trying to process like say events with respect to S3 object, say events, you can just click that. Probably anything like that, you can just say if you try to process this. Say you're trying to listen to events that are triggered due to DynamoDB changes data. You can this is since you have chosen the blueprint, it has come with that. You can probably skip it and choose whichever you want. You can choose the event type, whichever you I have told you here. You can find it. Like Alexa are the ones which is for the voice recognition system provided by AWS. For IoT, you can choose this. CloudWatch, if you want to listen to CloudWatch log data, you can just select this. Or we chose DynamoDB can use events, you can select any of these. If you want to execute your code on specific intervals, you choose the event as scheduled event. So probably you can choose any of this. Listen to any DynamoDB. Since I have chosen DynamoDB, you can choose any of the existing table. Here, I just choose something like that. You can choose the batch size, or you can retrieve your data as events. Batch size, you can change the batch size accordingly. The amount of data that you get in a single batch. And this is how you want your data to be provided in horizon or just only the latest data you want. Here there you get like you just upload it as package it. To Java, you can just make a jar out of it, and they provide another utility to package it specific to Lambda function. So just package it and upload it. With respect to Python, like they have a limitation, like put it in. You can pull all the libraries that you need or import into a specific folder. You can zip it. Okay. You can zip them and upload it here. So this has a limitation like up to 10 MB it can be uploaded, and if even under 10 MB, if it takes much longer, probably you can upload it via S3, because uploading via S3 will be an easier option where upload even if it takes longer, you can upload it to S3 and use it here. And a handler. This is handler. You specify the function which needs to be triggered once your function gets triggered. You can have multiple functions, multiple methods implemented within your Lambda function. However, you can have only one handler that will be triggered. It's similar to a main function in Java. You need to specify a specific handler. When any one function needs to act as a handler which gets triggered, and you can choose a role. You can either choose any existing role or you can create any specific role. In this case, I just create the DynamoDB event stream role, which will allow you to take you to the IAM editor, where you can just choose the appropriate roles. So if you are reading from DynamoDB, probably you need to enable your stream reading data permissions, like things like that. You can view the policy document, like which are policies that needs to be given. Specific thing would be like invoke function. This invoke function will be required by resources. Like say if you are trying to use S3 or if you are trying to use DynamoDB, they need to invoke this function. So you need to allow enable this policy. Invoke function you need to enable so that the other resources can invoke your Lambda function. So, and if at all you try to use any other resources within your Lambda function, like say SNS or any other service, like say S3, if you try to upload data to DynamoDB, you can just add those permissions here as well. So here in this case, DynamoDB get records, get chart. These are all for listening your streams and logs. So once you create this, asking like to allow it. So it gets added here. Your role is selected. You just specify the memory. You can choose the memory you can have up to 1.5 gigs, I guess, is the max they provide as of now. So 1.5 gigs memory queue. So you can choose the timeout whichever you want. You can choose up to something like this. Up to 300 seconds you can choose. And probably the enable now and enable later function will enable your Lambda function. So usually this is done later. You can test it once you can enable it later once you test your function. So you can just create your function. So I didn't upload a code. So probably you can enter your code here, any custom code you want, you can enter here. And you can just create your Lambda functions. I'll just show a Lambda function which is already existing. Probably simpler one. Something like this. Say this is a handler. So it just uses, just prints the value which it receives as events. You just try to print. Whichever you get, you print here goes. If you are testing from console, it prints there, or it gets logged into the CloudWatch logs. Whichever you return as events gets returned to the from where to the system where it gets invoked from. If you are invoking this from say API gateway, that gets your data that gets returned from here. Apart from this, it provides logging configuration. You can edit whenever you want. You can edit the configuration. However, the name or the runtime, like this, can't be changed. The type of Lambda function can't be changed. Even so, sir, you can add whenever you want. You can disable a particular function and you can add. And a specific Lambda function can also listen to multiple event sources. And from a single event source, multiple Lambda functions can also be triggered. So both way it works. So you can add the event source whenever you want. And API endpoints, you can add any specific API endpoints which will trigger this. Say if you are using API gateway, you can add an endpoint here directly. Monitoring. This is, so I guess this thing, as far as my experience, like logging is little bit poor compared to a regular Lambda thing. So the thing which you log gets logged in CloudWatch. Just you can view the number of invocations, duration, and errors, things like that. You can see here, and the logs you can find it here in CloudWatch. Appropriate, you'll find specific folders for specific Lambda functions you create, and you can look for logs here. So I'll just stop here and proceed with the. So I'll leave it to Saranan to take further slides from here.
So good afternoon, everyone. I'm Saranan. I have been part of Automaton team in 8KMLs. We have been working a product which mainly focus on AWS securities and AWS best practices. What Lambda gives us is, like, if you wanted to create an application without worrying about server, okay, so we can easily choose Lambda and we can mainly focus on only writing the code. So like maintaining the infrastructure, or like how to apply the patches, so everything, and scaling, so everything is taken care by Lambda. So when Lambda has been launched, it has been introduced as an event-driven computing. Like some event has to trigger the Lambda function. But in the latest reinvent, okay, what they introduced is, like, you can, like, schedule the Lambda functions. That means that no more event-driven computing, that also a scheduled manner we can trigger Lambda functions. Okay, so this gives us a lot of options to create more use cases with Lambda. I'm briefly cover like what all the like famous use cases. So since you can easily integrate kinds of streams with Lambda, okay, so if you have a like click stream analysis or like social media analysis, okay, so all these data can be pushed into kinds of streams. From there, like we can trigger Lambda functions and we can do a lot of analysis. Like we can push the data into Redshift, and there we can do a lot of like data analytics. The next use case is like media file transformations. So like he explained, like if you wanted to generate thumbnail image after uploading an image into S3, okay, the Lambda function can easily trigger after the upload event into S3. Then we can generate the thumbnail from Lambda functions and put it into another S3 bucket. Okay. Also, like media encoding, in the sense like if you are uploading a video uploading application, there we have to generate like multiple encoded videos, multiple format videos. So that also can be triggered after uploading the videos into S3. So building microservices is more mainly with like AWS API Gateway. So API Gateway provides like a lot of options to create REST endpoints easily. Like within minutes you can create an API endpoint. Okay. So the backend code will be running in Lambda. So what you have to do is like you can create an endpoint in API Gateway, and then you can attach it to a Lambda function. So you can like write code in Lambda function what you have to do. Like you can talk with the S3 or you can talk with other like external services, whatever, like Twilio or Algorithmia, everything. Then you can give the response into the REST API. The scheduled task is primarily for like the scheduled Lambda functions, like a log cleaning activity. Like we have an application server, okay, so we wanted to clean our log on the specific interval. Okay, that can be done via like a scheduled Lambda function, or like I have to push my data from like OLTP applications into data warehouse on the scheduled interval. Like every 30 minutes I have to run this query and push this data into data warehouse. Okay, so without worrying about like this can be like a said as like fault tolerant cron, because like if you have a cron, okay, so you have to take care of like what will happen if there is a failure in the cron, like, because the cron is like in a single machine. So we have to ensure that what will happen if there is a failure in that node. So like if you schedule the function in Lambda, okay, so they will take care of like the availability of the node. So the last one is DynamoDB triggers. Like when people are migrating from like a relational database into NoSQL database, so one feature they are missing is triggers. Like if you are talking about like MySQL or Oracle, okay, so trigger will be much useful like for some use cases. Like let's say after inserting into a particular row, you can audit the records, like who wrote that record into the table. Okay. So the trigger can be like updating into the audit table. But like when we are going ahead with like NoSQL DBs like DynamoDB, we are missing that trigger feature. Okay, with the Lambda, you can write trigger for DynamoDB tables. Okay, so this is like what we have implemented in our project. Okay, so we have like Automaton is a product which mainly focuses on AWS security and AWS best practices. So we have like multiple customers and we have like hundreds of jobs for each customers. So each jobs are running in Mesos Kronos. It's a job scheduler. All these data are pushed into DynamoDB. So like we have to process the data, because the job job results are pure JSON. Okay, we need a lot of transformations so that the nice UI can be built out of the data what we are getting from the jobs. Okay, so all the job results are pushed from Mesos Kronos jobs into DynamoDB. So we have streams, DynamoDB streams enabled. Then we have like multiple Lambda functions which triggered out of these DynamoDB streams. So one of the thing is like aggregating the result. Like as I mentioned, like you can move it to a data warehouse like Redshift. There you can do multiple analysis. And in our use case, like we are keeping a job history, like whenever the job is running and like what are the results and what point of time. Then next, Lambda is like updating the job status, like whether the job has been succeeded or failed and what happened to the latest execution. And like the third lambda is for Elasticsearch. Like we have a search functionality. The source data for the Elasticsearch needs to be like frequently updated whenever there is a job run. So we are triggering lambda functions, so which will update the Elasticsearch data. Okay, so like Muthu already explained, like AWS config is like a resource inventory service which will tell like what all the resource and like how they are interconnected and what is the configuration associated with the resources. Okay, in the latest reinvent, config rule has been introduced. Like config rule is continuous monitor to the AWS resources. Yeah, monitor built over the AWS config is config rule. So AWS config rule, you can use it to check your complaints of the entire infrastructure. Like for example, like if there is a security group, okay, so where the port like port 21 is across to the world, open to world, okay. So there is a like serious issue. Like if somebody is doing that, then you have to, like the IT administrator needs to be notified immediately. Okay, this kind of complaints can be implemented with the AWS config rule. Since it is more aligned with like what we built as our tool, so our tool as like in our tool has been checking the data like in a scheduled manner. Okay, so AWS config rule is like AWS config rule will tell the notification of this has been changed so that you can update. Like whatever we have running in a scheduled manner, okay, is not more needed. So we have like migrating our entire platform into AWS config rule, which will tell like what all the resources are changed recently and what was the like complaint checks we are missing, all these things. So now Muthu will show the like DynamoDB streams demo and the API gateway demo.
So he just explained about like one of the use cases which we implemented as part of our project Automaton, where in one use case like we try to process the DynamoDB streams data, which is where we get data from job results. We get data from jobs. The results are getting stored in DynamoDB. We process the results. And take multiple actions from that DynamoDB streams data. One use case is like transform the data and store it back into DynamoDB, like maintaining an audit history. We store it again back into DynamoDB. This is one of the Lambda functions which we do. Other cases like storing it to Elasticsearch, as you mentioned, things like that are there. So I'll just explain about like one of the functions which we did earlier. Like say I'll just explain about that one of the functions which we.
Job history.
So this is tied to a. This is job result history. This function is tied to a stream data from a job result table. So this posts data into this receives notifications from stream data from the job result table, and it tries to update into job result history table. This is one of the activity this is done. Since this code is in Java and it is uploaded, I will not be able to show it directly here. So this is one of the use cases which we maintain. Probably I can show it from DynamoDB. It is here. So this earlier we tried to maintain history here itself. This is one use case like where we try to get job data and store the data and try to maintain history. So to maintain a history, we tried to create a separate table and we created a Lambda function to achieve that. So the job history table gets updated for every row that gets inserted there, and the other data gets cleared. Only a single row gets maintained there. So history maintains all the records. So the actual Lambda function just try to receive data from there, try to make some transformation over the data and store it here as history data. So this is what this function actually does. So the function takes data from there and puts it here. This is one of the activity which we do there. And apart from that, this function has functions to do with the Elasticsearch as well. DynamoDB Elasticsearch. This takes care of uploading it to Elasticsearch. And yeah, we have job results, run ID data splitter. These are all like different set of functions that act in response to specific data, specific tables, events. So these are all the use cases which we do here. Yeah, apart from that, I'll just show a demo of how it is integrated with the API gateway. One function, like this is a Python function. So it just, this is the Python Lambda function which we have written here. It has a handler, it just prints a message, it returns a message. This is a simple Python function, Python Lambda function written there. So we have API gateway here. So API gateway, if you are not aware of, it is, as earlier said, it is used to create REST endpoints. You can just directly connect your REST endpoints to any Lambda function of any language, like whichever it is. Like Node.js, you can use Python, whichever function. I tried to link it with the Python function. So I just created a resource. I just deployed an API. It is linked with this ARN. Like say this ARN is associated with that function which I have mentioned. It doesn't have any authorization. I just mentioned the key there. So I can either do this from here, I can test this from here. So this is the function which we receive in gateway here. If I test from here, since I have invoked it there, it is the instantaneous response, synchronous response. So I get the message here as request body. Or you can, if you're similar, how you invoke APIs, REST endpoints from your Postman client or any other REST clients, you can try it from there. So from Postman client, it just API gateway provides you an endpoint. So you can just hit this endpoint with the appropriate keys. I just already tested it here. So if you just try to send the request from here, I have provided the headers. This key is provided by the API gateway. It just returns the message. So integrating this with API gateway, you eventually get a beautiful way of connecting non-Java services, connecting with the REST endpoints and making things life easier. You can easily edit the code apart from changing your REST endpoints, things like that. So easily creating services, microservices easily. So this is a basic use case of like how you execute with integrated with the API gateway. Lambda limitations currently which we face, you can have only stateless applications. Stateful applications are currently not supported. So all your functions needs to be stateless. Maintain your state apart elsewhere, storing it in any RDS or say somewhere else. And access to machine is restricted, so you cannot log into hosts. So the Lambda functions runs on AWS infrastructure. However, you don't have access to hosts. It is maintained purely by AWS. And you currently have a memory limitation of like say 1.5 GB RAM. So this is currently, if you face any resource that requires more than this, probably that will act as a limitation for you. And failure handling, like say based on our experience, I feel like failure handling is little tough, like keeping track of all your failures, though they have retrace, like maintaining your failures and keeping track of your messages is little tough as far as our experience. And logging, especially logging, with respect to logging, it is not complete logging. Apart from what you log inside your function, you don't have any specific log that is posted to CloudWatch specific from Lambda. So probably improving these will make life easier for developers using Lambda especially. So that gets to the end of our Lambda session. So any questions you have for both of us?
Any customer use cases where you have been able to use Lambda?
So we our job, we have what are all things we have in pipeline is like we try to receive notification using SQS through to our system, further which we will be processing our data. So Mesos and Chronos have been running on typically on EC2 instances again, so that need not run. And we have been scheduling some jobs or we have been manually doing to shut down instances during our offers, things like that. Over the weekends we have been shutting down those instances since we are not running. Since Lambda function holds that, so we are not getting charged when we are not running it. So apart from that, we get charged for whatever resource we use, except for the EC2 resource which we charged. we are getting charged. So mainly we have reduced our bills of EC2 instances which we are running for schedulers and other application servers which we are running. So this is one key thing which.
Other than building, like what we have achieved was like we don't have to worry about the Mesos infrastructure. Like we don't have much auto scaling and all installed there, but like still we have to do the log cleanup there. Like so there's a Mesos like mastery sub, slavery sub. So all these things we don't have to worry about them, and like we can directly write Python programs and put it in Lambda, then everything's done.
Goes off the network and comes back a few hours later, right? So those kind of use cases, you don't have to run a long-running backend, but if you can have a computing environment which just responds to events whenever those events happen, right? So it fundamentally changes the way you think about infrastructure, and those use cases you will definitely see a lot of cost savings. Yeah. Plus it removes the management overhead, so where you don't have to go and maintain and have a way to manage the infrastructure.
So AWS is basically doing the auto scaling for you, instead of you having to do it per se, right? I mean, someone has to scale at some point.
Yeah, yeah.
So the question is like, there must be a delay. Has to be. Like for example, if you were doing auto scaling using your own auto scaler,
Yeah.
You set up like limits as to when you want to scale, how long the transient period is going to be.
Yeah.
So have you come across something like, let's say you had 1 million or 10 million or maybe 100 million jobs
Yeah.
that were queued up? How quickly is Lambda able to read them, or have you seen some edge case scenarios happening in this situation?
Yeah, so it's a good question. So Lambda is now being used use cases like ad exchanges, right, where real-time bidding for advertisements are being done by ad exchanges, where the SLAs for these ad exchanges are 100 milliseconds, where the ads that we see on our mobile apps and browsers, right? So what happens is when we go to that particular page, depending upon who we are and what kind of anonymized data the ad exchanges get, the ad exchange goes and bids for ads to be shown in particular real estate, and the SLA for these companies are 100 milliseconds, right? And imagine the scale at which guys like AdRoll are operating. So these are millions of ads being served every hour, right? So Lambda is able to scale for those kind of scenarios as well. So it's just not auto scaling by AWS because it is a managed service that we operate. So while we would scale by ourselves, but it's just purely not, where we have taken a bunch of EC2 instances and just put auto scaling rules for those EC2 instances. We have fundamentally thought about how to handle event sources, how to make sure we are able to scale dynamically. Yeah. So it supports a very, very large use cases, millions of events. So we have real world use cases for that.
Okay.
Yeah.
Another question is like, when you've got your own servers running, so they are waiting for jobs to come, right? So they are like, as soon as you've got a job in queue, it's immediately going to pick it up and run.
Yeah.
How does it happen with like Lambda? Because since they're not charging you for the wait time, and they're charging you only for the compute time,
Yeah.
are they like, so this is all under the hood, like obviously they're not exposing that information to us, but I'm just asking since you work on it for 3 months,
Yeah.
are they like running it at a lower level, like you don't see it, but I mean, that's how they can immediately, process within 100 milliseconds, right? If they have to spin up instances and then run it,
Yeah.
it's not going to work that way.
Yeah, so obviously, I won't be able to tell you a lot of details, but obviously instances do not come up, like when an event occurs. So obviously we are kind of running a fleet, and the fleet is basically it's a multi-tenant shared fleet that can run multiple Lambda functions, and just like how, so this is basically how virtualization happens on physical hardware, right? So where you are now able to pack more VMs on a single physical hardware. So when you go and request for an EC2 instance, how are we able to go and locate for a physical resource where we go and spin up a virtual machine in under a minute, right? So the same thing is happening where can I run an isolated code, right, on a virtualized environment? That's the kind of abstraction that the virtual machine is offering, right? And we are able to schedule those functions dynamically. So That's how it's being done. You don't see any delays because we are able to kind of predict and manage the infrastructure for Lambda functions.
Actually, what you said, it is not a one-to-one kind of thing. So it's not when you try to run the Lambda function, EC2 instances, spin up, it is running. So every hundreds of EC2 instances will be running and thousands of Lambda jobs which are waiting in it. So they will have an algorithm to predict their load based on their EC2 instance. And that will be, there is kind of a passive, it's not very
Yeah.
So they have their own algorithm to do it. So that's what is going into that.
I mean, I don't think that's the way they would have done it because, I mean, just imagine, right, if they're going to have a common fleet of machines accessing multiple resources, the whole concept of multi-tenancy goes for a pass. You're able to provide, I mean, if you have dedicated hardware, a lot of stuff, resources I can choose based on that. My AWS offers you that personalized, I mean, either running your dedicated hardware or your placement rules, and you access resources like that. I mean, I don't think it will be a common fleet. Maybe they would have a fleet per account. I mean, again, I'm just guessing. But your cost is going to be amortized when you run it on an entire set of accounts where it's just be a very little overhead the Amazon has to incur per account. But the cost, you get, I mean, that's the cost of doing business.
But I think because they try to run for every customer dedicated instance, it's going to be a good cost. But I assume there is a new shared instance. So then it will be a very cost effective one.
The placements go for a toss, right? So my access to resources, other resources, based on the
It's
availability.
stateless, stateless
No,
plane.
the external resources. My RDS is running on an AZ on US East 1 C, I mean, US East 1A versus Lambda running on a machine on US East 1E. The access cost, the latency, everything goes for a toss. So I don't think it's a common fleet. Definitely not how they would have done it. It would be more.
It can definitely be a common fleet within each region, right?
More within AZ.
I think there are two answers to it. One is we now allow Lambda functions to be created within a VPC, right, which would come eventually, right, within your VPC, right? So when that happens, obviously, it's running on within your VPC, within your environment. But then you can also have Lambda functions that runs out of the VPC, right? So it could be a combination where some portion could be a common fleet, and when you decide to run it on your VPC, you may throw up infrastructure for specific to your account.
So currently the Lambda functions are in the default only VPC or they are on the VPC at all?
They are not in any VPC. It's just on some infrastructure on AWS.
Is there a concept of like how you have, for instance, there's a concept of reserve instance, like you guarantee AWS that you're going to give them at least 3 instances of business. Is there a similar concept or something where you're guaranteeing that you at least have like 1 million invokes per month or some sort of reservedness nature in that?
Not today. So I mean, it's a pretty new service, right? So we don't have like a reserved Lambda compute instances or whatever. So we don't have it. So what I imagine is that you'll have to move away from instances, move away your thought process from instances, go to basically where can I get any amount of compute resources depending upon my events. That's about it. So move away from virtual machines and instance thought process. Yeah. So maybe that could be like a billing construct in future. So where I know that I'm going to run 1 million Lambda functions every month. So can I go on like a reservation and probably have some savings, right? So something like that. Could be a billing construct in future, but not today.
So my question is about the limitation of 1.5 GB RAM.
Yeah.
So what is actually used? Probably I need to bring it to some point. Why I need to worry about that kind of?
It's the amount of memory that's available for a single function run. So you're giving us a piece of code. We run it in some environment, right? And so depending upon what you have written within that function. So let's say you are doing a image conversion, right? So which means you're probably blowing up a 20 MB file to a 100 MB and then do some kind of a processing, right? So which means you need some amount of memory. So depending upon your use case, we ask you to decide how much amount of memory would be required for a single function run.
So for example, if I have around 2 GB or 10 GB of my video is stored in S3.
Yeah.
So if I try to use lambda function for some kind of encoding or decoding or to reduce it, so then I can't use it because it is limitation of 1.5 GB.
Yeah, so if you need 10 GB of memory to just encode one video.
I have one video of 10 GB.
Yeah.
So now I want to do some processing on it. So I give input to the lambda function and lambda function do some kind of processing activity. So for this kind of use cases, that will be restricted?
Yes, you will not be able to do it by a lambda today. But again, it depends on how you are encoding that video, for example. So if you are, it's a 10 GB file and you split that and then do multiple channels and then encode each channel, then you could still do it by a lambda. But I would imagine you not using lambda for that. You'll still use probably EC2 instance or the Elastic Transporter service for that.
Now, what kind of encoding service you use those? Again, this is just samples. So probably
Yeah,
in
it's a
this
diff-
area like that.
yeah. So it's lambda is not like one fit for all use cases, definitely. The primary use case would be a lot of short-lived events. So the time modes of 300 seconds that was just very recently increased, but the time modes were 60 seconds before. So we anticipate people to use for a lot of short-lived events, but people use for a lot of wide use cases, so we increase the time mode.
So how AWS recently the redevelopment their how to say IoT platform.
Yeah.
So this lambda is also part of the
Lambda is part of the IoT platform. Yes. Cool. So I think we're running out of time. So let's